Hello everyone, welcome back to my Chem Corner. In today's video, we are doing another question on chemical bonding and molecular structure, which is question number 4.4. Here it says draw the Lewis structure for the following molecules and ions: H2S, SiCl4, BeF2, CO3 2- and HCOOH. So in the last two videos that I did, I spoke about how to approach a Lewis structure. I've also spoken to you about when you know how to do a Lewis structure for an atom, you should also be able to do the Lewis structure for an ion, where you have either loss of electron or gain of electron. Identifying the valence electrons, identifying the group number, and so on. So in this video, I'm going to talk about how you're going to draw a Lewis structure for molecule and its respective ion, um, using the same approach we did in the previous two videos. All right. Now, for those of you who are still confused about how you're going to approach, how you're going to draw all of that, I would suggest before you watch this video, please go ahead and watch the previous two videos that I did on Lewis structure with respect to questions from the ncert textbook itself. So it's easier for you to uh, approach this particular question where you have to draw an entire molecule. All right. So here, first of all, uh, you have these molecules given. Now, if you do these molecules, I think it should be easier for you to do any other molecule that is given to you in the exam. First one is H2S, hydrogen sulfide. All right. Now, from this, we have two nonmetals. One is a hydrogen, the other one is sulfur. Since the topic is related to chemical bonding also, this question is coming in the chemical bonding chapter. Remember that any element that combines to give you a molecule, you should be able to also identify whether it is an ionic bonding or do you have a covalent bonding in it. Now you have hydrogen and you have sulfur in this. Both of these are nonmetals, and when you have a bonding between two nonmetals, this compound is a covalent compound. Okay, or you have a covalent bond. All right. Now, we all know that the structure for H2S is this, right? You have a sulfur in the center, which is a central atom, and you have hydrogens on either side. Same approach you're going to have. You are going to look at the valence electrons in each of this and then draw the structure. So sulfur being the central atom, it belongs to group 16. Okay, group 16 means 6 valence electrons. All right, so now let's put that here. You have sulfur, you have 6 valence electron. I drew 4 of it, and now I have 6. So I have 6 valence electron. Then you have hydrogen. Hydrogen has only 1 valence electron. All right, hydrogen has only 1 valence electron, so it is being shared with the hydrogen, and I'm going to denote the electrons of hydrogen that is shared with it as a cross. Now this is going to be the Lewis dot structure for hydrogen sulfide. So when you have 2 electrons, this will form a bond. All right, see when I try to draw a bond here, this is going to be a bond here that will resemble the structure I drew up. So one bond means you have an electron from this and you have an electron from this atom. All right, now that is going to be the Lewis dot structure for H2S. Okay, now moving on to your next compound, which is SiCl4. Now SiCl4, silicon. All right, silicon belongs to group 14. It belongs to the same group as carbon is present. So group 14 means 4 valence electrons, right? And Cl, chlorine, belongs to group 17. 17 meaning 7 valence electrons. Okay, now, so silicon is going to be the central atom. Around it I need to have 4 valence electrons, so I'm going to put 4 of them. Each of these are going to be shared with 4 Cl atoms. So I'll put one Cl here, one here, one here, and another one here. Now each chlorine has 7 electrons. So let's start with the one here. I'll have 1, 2, 3, 4, 5, 6, and 7. So you see around this I have 7, this chlorine. Okay, so this is the one that is bonding to silicon. So one cross over here from chlorine and a dot from here is bonding with silicon. Similarly for the other chlorine, 1, 2, 3, 4, 5, 6, and 7. Okay, and you have the bond over here. Similarly for the next one, I'll draw 7 of them and I have a bond over here. And similarly with the chlorine here. So if you see, chlorine has 7 electrons and silicon has 4 of them as shown. Alright, now this is going to be the Lewis dot symbol for SiCl4. Then next one is BeF2. BeF2 is a simple one. Beryllium belongs to group 2, which is your alkaline earth metals. Group 2 meaning 2 valence electrons. Alright. Now, fluorine, just like chlorine, belongs to group 17. So it has 7 valence electrons. Right? So Be is going to be the central atom. And either sides, I will have 2 fluorine atom as the formula says. So Be should have 2 valence electrons. So I'm just going to put 2 electrons. Okay. Now fluorine is going to have 7 each. So 7 is 1 here, 2, 3, 4, 5, 6, and 7. Now this is where the bond is with Be. Similarly with another fluorine, 1, 2, 3, 4, 5, 6, and 7. Here you have the second bond. So this is going to be BeF2. Alright, you should ensure that the correct number of valence electrons are present around each element in the molecule. And now the next one is an ion. A carbonate ion, CO3, 2 minus. Now, carbon is group 14, therefore 4 valence electrons. Oxygen is group 16, therefore 6 valence electrons. Alright, now let's try to arrange. Carbon is going to be obviously in the center. You will have 4 of it around them. Now the reason why I just put arrangement like this is because I just have 3 oxygens. So I'll put 1 oxygen here, second one here, and third one here. 3 oxygens. Now first oxygen, let's see here. 1 electron is given here. You need to have 6 electrons. So 1, 2, 3, 4, 5, and you have the 6th one here. So you have 1, 2, 3, 4, 5, 6. I will tell you what that is. I'll come to that. Similarly, the one here is also the same way. Alright. And the one here is a double bond. So I'll have 2 here. and I will have 2 here. Now, how is the structure in actual? Here you have a double bond with the oxygen. This is a single bond with a negative charge, and this is a single bond with a negative charge. Now, this is the actual structure of a carbonate ion. So, this negative charge is this here. Okay, and this one is here. All right, so that's why you have this written with 2 cross. Now, I'll put a 2 minus. Okay, now this is going to be the Lewis structure for a carbonate ion. And the last one is of course formic acid, HCOOH. Now this we know as a carboxylic group, so obviously carboxylic group has to be like this. And carbon should have 4 bonds around itself, so you put the next hydrogen here. So when I draw this again, carbon should have 4 bonds around itself. It has 4. Then it has a hydrogen here. It has an oxygen here. It has another oxygen. This oxygen is also bonded to a hydrogen. So now I'm going to denote the electrons of oxygen using a cross. Okay. Now that's done. I'll just change the color for the electrons of hydrogen and put a cross here as well. These are the elements that we just came across already, so that's why I did not write the group. Carbon has 4 valence electrons, therefore there are 4 here. Hydrogen only 1 valence electron, so therefore 1 electron here. Oxygen has 6 valence electrons. So it's very important that when you do a Lewis structure for an atom, for an ion, or for a molecule, it is important that you know how many valence electrons are present in each atom, so that in the end when you draw the structure, the number of electrons around them are correct. Alright, this is the basic thing that you should know in this topic. And once you're thorough with this, then it will not only help you in this chapter, it will be of great help when you look into organic chemistry chapters as well, because where you're losing an electron, where you're gaining an electron, you'll be able to identify the valence electrons, you'll be able to identify whether they're losing or gaining and all of that. All right, so it becomes easier in that way as well.